Hello Internet! Today we're going to be returning back to our Mixer game. So if you're not familiar, Mixer is a streaming platform. It's like YouTube's live streaming, YouTube gaming, and then Twitch. But it's the focus of Mixer has always been on like really fast response rates. So you can actually see what I would stream about 200-ish milliseconds after I actually streamed it. Assuming you're in my region, it gets a little bit less the further away you get, just because of speed of light issues. But the cool thing about that is that you can actually that's low enough latency that you can actually interact with it. So one of the things that we tried to do a while back is build a game for Mixer where you would actually play a character and do that. Part of the issue that we were running into, that I was running into, I didn't really show it on stream. It's really hard to design something that kind of works for this thing, so you can actually play it with that 200 millisecond ping effectively and still have a fun game, and in a way where it's played. Mixer has ideas for, say, a control, so you can have a joystick and you can actually build these controls. So you can have a joystick below the stream and everybody in chat can see it, and there's buttons and stuff, so you can actually interact that way. So the idea here is we're going to make sort of mini games, and basically it's going to, I'm calling them stream savers. So there's times when you're live streaming, a lot of the streamers have had to do this, where you have to step away just for whatever reason. And so if you need to do that, most people just have like a blank screen, or they'll just leave it up and watch their cat do something interesting. This sort of, the goal is to be able to host a quick game, something that starts up really quick, that there's no real introduction, whatever. Just something that the stream can play for a minute or two and just sort of do that. I'm hoping that we can just kind of build like mini games this way and kind of flush out what works and what doesn't work, and then build something bigger from that. So this is sort of the MVP, the minimum viable product for a streamed game that's done in real time with theoretically tens or hundreds of people. So that's sort of the idea here. Don't know if it's going to work, but that's what we're playing on. So what I was thinking for the most basic thing is just going to be a balancing game. So there's going to be a balance beam effectively suspended in the middle, and I can actually just build that quick. It's going to be easier to show it anyway. So we can actually, I'm thinking probably 2D for this, but I'm going to use 3D objects so we can kind of switch between them if we want to. So there's that, and we're just going to add another one on top. This is strictly just to show. And so effectively there's this beam, right? And your goal is to drop blocks onto this and keep it balanced and stack as many high as you can. So you want to go as high as you can. And the thing is people watching the stream are going to be the ones dropping it. So there's going to be like 8 buttons or 4 buttons or whatever. And that's just going to drop them in the 4 columns or whatever. And everything's going to be physics-based, so it'll just fall. At least that's sort of the idea. So think of it like if we made this a rigid body. I'm going to regret doing this in 3D because I'm doing all 3D physics, but then put a cube up here, add a rigid body to that. This is the game. And so you just drop that. Probably don't want it to rock like that, but that's fine. It's physics-based, so it's going to be kind of weird. But the idea is to prevent that from happening. So it's a little bit too easy to lose right now, but I just built that in less than a minute. So what we need to, the goal for this video is to make it so you lose when that platform falls off. And that's pretty much it. We're not dealing with dropping these blocks at all. That can come later. And that'll probably be a 2-part thing. We'll do just manually dropping them with keys or whatever, and just getting it to actually resize and grow the camera and stuff. But then we'll also handle syncing that up with Mixer and actually doing that. So if you're interested in playing with this Mixer stuff, they have a thing in the Unity store. Just if you search for Mixer Interactive or just Mixer, it's featured on the Unity store. And so you can just start playing with it. It's free. And all you need is a live stream or an account on Mixer. So there's that. I think it's cool, but I don't know. I haven't seen anybody do this, and I've been trying to do something about this for like a year. So anyway, we are going to just leave that there. and let it do its thing. And really all we're going to be working with is this. And I think we're going to be working in 2D. It just makes way more sense. Could we do 3D? So what if we did like a grid that was 4x4? So instead of this, you had this. And then you kind of viewed it from this angle. And your cubes were sort of in this orientation. So you could drop them like this. And then, so this should balance, I assume. Yeah. But then you kind of have to stack them that way. And it's just sort of building up each tower independently. And that way it can, it isn't actually really any different. There's no difference to it at all. I don't want to do that. But as you like move these, the only difference is that it'll make it 3D. And apparently more stable, because that didn't tip it over. Cool. Okay. I had expected that to just fall over. I'm trying to... Did I not? No, I added rigid bodies. What's going on? That... I took off the collider, didn't I? The rigid body? Yep. Okay. I was totally losing my mind. I was expecting that to just fall. But anyway, we could do it 3D or we could do it 2D. The mechanics are actually probably going to be the same, because all I'm going to be doing is checking a dot product of this platform. If it falls upside down and is below a specific height, like below the pivot point down here, we're calling that a loss. So it could actually like slide. The reason we're doing the dot product and the thing is because it could actually like slide like this. And then let me adjust everything that I don't want to adjust. Do something like this. And so it could still, I don't know how, but it could be balanced and the origin could actually be below, but the point, it'd still be facing up. So somehow it'd still technically be valid. But if it were to flip completely over like this, you've lost. But if somehow through some crazy act of physics, you manage to get it to do a full 180, so it's still back up like this, but it manages to just, land here. That's cool too. I would suggest you were probably cheating, but that's cool. So that's an option. I'm going to go the 2D route, just because I think that's going to be just easier to visualize. We're working with less angles of freedom. The dot product math and y height is all the same, so there's nothing really changing there. It's just hopefully going to be easier. So we're going to take all these rigid bodies off and all the box colliders as well. I could have done all of those at once. All right, so we're going to take all of those off and we'll add additional box colliders, because why not? But we'll make them 2D, and that should be good. So now we need 2 rigid bodies, 2D rigid bodies like that. And we should have everything behaving effectively the same as it was before. But I should be able to like drag this around now, and it still falls, but everything is in 2D. So I can't mess with the Z-axis and cause anything bad to happen. So I could actually like take this cube and just throw it way back there for whatever reason, and it's 2D. So there we go. Because we're making this 2D, I'm going to switch this to a orthographic projection, which just means the lines are straight. If there's a perspective, it gets wider the further out you go, and that just kind of makes things shrink as you go further. We can get rid of that, and now it should look 2D with a backdrop. And we have some nice off by 1 errors there in our physics. Cool. Let's get rid of our skybox and just make this that gross blue. Why not? make it less gross. There we go. So there we go. There is our game. Now we just need to name things. So we're going to have this be the pivot. That is not what that's called in a lever. It's called something else. I should know that. That's like basic physics stuff, but oh well. Then we have the platform and just a cube. Cube. There we go. Cube is off the screen, so we're gonna pretend like that's not there. The pivot point doesn't actually need any scripts. There's nothing there. So all we really need to do is have a game monitor. What do we want to call this? The platform monitor? I don't know why I want to call something a monitor, but we're going to do that. And so we get that. That is going to effectively monitor if we win or lost. So this is pretty much where all of our game logic is going to happen. Nothing else is really going to go on. And I think that should be the only script we need. For now, I'm just going to actually call out and just print out, you've lost. There's going to be some more things. I'm kind of hoping to just put all these games in one. So you'll download it and then you can pick like 4, or the stream can select them in chat or whatever. That's sort of what I'm hoping for, but that's farther down the future, or farther down the road. For now, we're just going to try to get this one game working, get it interactive. I have an actual PC, so I can actually set up a stream that literally just plays this 24/7. So that's sort of the first step, is to just get a constant stream of this game, and then we'll get it constantly updating. This will hopefully turn into an open source thing. That's the plan. So for now, we have our platform monitor. We are going to have some sort of public transform, which is going to be our monitored, our origin. We'll call it the origin. So if you fall below the origin, I don't really know what else to call it, then you lose, as long as your dot product is negative. And so in order to calculate that, I don't think we actually need anything else. This should be fairly straightforward. So it should just be if our origin dot transform dot position is dot y. We're just working on the y-axis. It doesn't matter if it shifts on the x-axis. So if the y position is greater than this transform dot position dot y. So if our current platform's position is below the origin's position, we're in trouble. And so then we need to check for loss, which is just going to be a dot product. And the cool thing is, because we're doing it this way, we aren't doing the dot product every frame. It's not really a savings, I guess, because it's not that complicated of a thing. But if we do it like this, we don't actually deal with it unless these change. So we need a dot product. That's actually fairly easy. We can actually use 3D vectors for this, so this will actually work in 3D if we ever change to that. All of this will. So we can do a vector3 dot dot. And so the way a dot product works, if you're unfamiliar, it's actually really cool because it's super handy. Imagine you have 2 vectors, right? You have one pointing in this way and one pointing in that way. The idea is you want to find the angle between them. A dot product lets you do that, and what it will do is it will calculate a difference between them. So if the 2 vectors are in line with one another, if they're parallel in the same direction, you're going to get 1, or the length of the vectors. For normalized vectors, like we're going to be using, that's 1. If they're in opposite directions, you get -1. And then if they're perpendicular to one another, so one is at a 90-degree angle to the other, you're going to get 0. So this should be the cosine, arc cosine? One of those two. I'm pretty sure it's the arc cosine of the angle, and so you can actually just use that to derive what the actual angle is. And that is kind of handy for a lot of things. In this case, it's really useful for seeing if we're facing in the same direction. You can also use it for detecting if something is in a cone, or other things like that. So for this, we just need our vector up. So it's going to be our transform.up, and we're just going to compare that to the world up, like so. So this is actually just looking at that and saying if this is greater than 0, less than 0. So if it's less than 0, then that means we're more than 90 degrees away from up, which means we have to be some angle of down. I guess that's a way of putting it. And so if that happens, then we've lost. So we just do debug log you have failed. Yay. Cool. So that I'm pretty sure is the entire thing. Isn't that interesting? That's pretty interesting. So I need to attach this to the platform. We can just do that. Give it a pivot point, like so, and then test it. And this should hopefully prove that it actually works. So we've got our platform, we've got our pivot, we've got our cube. Let's just slide that over. You'll see our console has nothing there. So as I move this over, it should fall. And then we get this you have failed a bunch. And it's just rotating, so we're going to get it a whole bunch of times. We just need to trigger it once. So to make sure that happens, I'm actually going to have a game state. I don't know if that's a great way to name it, but we're gonna call that what it is. Game state. I'm gonna regret this because I'm gonna have multiple of these, one for each game, which is not great. We'll probably have to rename this, but I'm gonna keep it this way for now, and we can come back to it. So we'll have a bool, which is just has lost, and we're going to have another bool for int score. We're not going to use the score for now, but I'm just going to put it there so that it's useful. And I think we can make these properties because I have an idea on how to make this work. So we have has lost and score. We're going to capitalize those so that ReSharper doesn't get angry with me. And there we go. So that is our entire class. Isn't that interesting? So we can create a new game object for this. And we'll just call this our game state with a capital T because I typed too fast. There we go. Game state. Put that at the top so we don't lose it. And this is just going to have that game state. The problem is our game state and our platform monitor, they aren't talking to one another. So we have to actually make that happen. And in order to do that, we can actually use an event. Kind of mixed up the words there, but there we go. That's not what I want. It's called a Unity event. Unity events just extend normal C# events, so they're more or less the same thing. But Unity events kind of are just, yeah. I don't know. I'd use Unity events in Unity and not outside of Unity. But for this, all we need to do is pass in something. I don't think we need anything, so I'm actually going to... I guess we can do that. Pass in a boolean for if you've won or lost. All it's asking for, that generic argument, is just going to be the value you're passing in your event. So the idea of these events is something is going to call them. In this case, we're going to replace this debug.log with a Unity event. So instead of just logging out, we're actually going to set something or send a message. We're going to send a message and things can subscribe to this and say, I care about that. So in this case, we're going to say on game lost. And so instead of debug.log, we can actually keep that there and do on game lost. And we want to invoke it with our argument. And our argument is just going to be true because you lost the game. So now that's all we need to do. There's no hooking up here. We don't need to actually touch that. We can actually do all of that from here, not here, from the platform. And so if it comes, what? Hold on. Why didn't that work? Does not match ruled. Okay. Officially confused. Oh, does it not? So Unity has this thing with events or with generic arguments. It doesn't do generic arguments in the inspector. So we can actually write in an inspector to do that. But if you use the generic or you use the generic arguments, it's not gonna work. It's not gonna show up here. So what we need to do is give it our game state, and we want to set a function, which in this case should be setting our has lost to true. And so when that becomes true, then we know we've lost. We're not going to be able to see that, but we can do some tricks with Visual Studio to actually inspect that. I think that's better than just making it a public field, because later on we can actually tie events. So instead of just everybody watching this platform monitor, I don't really want that. Instead, I want the platform monitor to find the game state and say, hey, games, this person lost. And then this game state is actually going to update everything else and let everything know, like the UI, to show a score screen and a high score screen or something like that. So all of that's going to happen outside of this. So score has lost. Let's do, well, what am I doing? We've already set that. I need to set a property here. Yeah, let's set a breakpoint, attach to Unity. This is going to attach Visual Studio's debugger to Unity, so we actually are watching what's going on. If I start this now, we shouldn't see anything, or it shouldn't stop. But if I make us lose, we should see a message or a breakpoint get hit when we hit that set for that property, because that's what's going to happen here. Or not. So if I pause this and go to our game state, can I use the immediate window? I don't think, I've never tried that before. We're just gonna, So that didn't do what I had hoped. Let's make this, just so I can see, I could make a public, I could make an inspector for this, but that's way more work than I want to do. So we're just going to do has lost and create that. And then our get in our set is just going to return has lost. We were going to do this anyway. That's sort of all those events that were going to get triggered. We'd need to do this in order for that to even work. But now I just have to do it now. So has lost equals the value. There we go. So this should effectively, it's just pulling, instead of using the implied behind the scenes field for this property, we're actually just creating one. So it doesn't actually do anything different at all. But this way we can actually see it because it will be exposed in Unity's inspector like that. So now if I start this, we should see that go get checked. And that means that we're actually losing the game. There we go. So you actually lose when it falls off. So now that we know that's happening, the next step is going to be to actually drop those blocks, because I don't want them to actually move. So we're going to be playing a little bit with the physics to actually make them like drop and kind of stick. And then after we do all of that, then it's going to be just tweaking all of this, adding some UI, and getting it out there. So yeah, I'm trying to keep these short. Wasn't super short, but yeah, if you guys have ideas for other games or something that we could do with this sort of format, it might kind of make it a little bit easier to figure those out after we get this one working. But if you have ideas, let me know in the comments, or if you are, I don't know, have ideas on how we could improve this, let me know. But that's it for this video. So until next time, see you, Internet.